So let's talk metadata harvesting. So issues with the retrieval augmented generation pipeline and unstructured data. As we said in the 80s and 90s, garbage in, garbage out, right? So if you have inconsistent quality of data, or you can't get to it, it's low performance, then you're not going to have good responses from your your GPT, right? So how do we fix this? Specifically with unstructured data, it's everywhere, right? And what I mean by that is it's on Windows file servers, it's on a NetApp, it's dispersed across the globe. It could be on SharePoint, could be on Box, could be on Dropbox. And this is 80% of your data estate. So how do you get the relevant information out of your unstructured data to your AI tools so that they know what's available to them and can provide good responses? The answer to this is metadata harvesting. There are ways to create structure from your unstructured data, get the metadata from it that is relevant to your business, right? So the key is that it is relevant to what you're trying to train your model on. And the way to get that information is obviously to scan it and create a custom schema that is structured, which basically contains that information that you're trying to train your model on. And that in turn will make everything go faster, right? Because now what you have is a structured location that your model can query, and it can do a couple of things. One, it can query information about the data set, and as the slide reads, it can actually ask for the full information set in the format in which it talks. So models tend to talk in API, SDK, SQL query, webhooks. That is not the language of your unstructured data, which tends to be NFS, SMB, right? S3 on the back end. So we have to transit that data to the model in the way that it's expecting to talk. And that is that movement of the data. So on the left, you have the issues, and on the right, you have the solution. And it's a very straightforward solution, which is structure your unstructured data. And that's exactly what Symphony does, right? With Symphony, what you can do is extract all of the relevant intelligence from your unstructured data, and then do something with it, which is automate the data motion. So we're going to talk about what it means to bring structured, unstructured data, how we do it, and then what are things that you can do once you have this intelligence to enable data motion. And data motion is not simply storage tiering. That's one of the things. But there's a lot of other things that you can do that would be considered motion. And then lastly, all of this sounds very complicated, but you have to change anything that you have. So I'm not asking you to get rid of everything you got and buy some magic tool and aggregate all of your data into one spot. That's not realistic. It's not possible. So the opposite indeed is true, where you don't have to change a thing, right? Keep your data where it is. There's no need to copy it. There's no need to move it all into the cloud that's relevant, which is what people are doing right now to train their models, is basically making copy of all relevant unstructured data. And it's a human that's trying to figure out what's relevant. In most cases, they're going to be wrong or miss something. So how about give the model access to everything and create a metadata catalog around that? So this is where Symphony fits. It fits in between all of the things that you already have. And we're going to spend some time on the slide kind of breaking it apart over the next 3 slides. But what you already have are users. And those users could be automated users like an LLM or an application. It could be a traditional user. It could be some kind of ETL tool. And all of those folks, I guess, will talk API or SDK, right, to Symphony. On the back end, you have every type of storage. And that storage can talk SMB, NFS, it could be basically HTTPS, the SharePoint, could be S3. And this is where it gets really exciting. You already have actionable intelligence within your enterprise. On the right-hand side are all those databases or all the tools that make databases. For example, Splunk makes a database in the back end. Varonis makes a database in the back end. And then obviously the traditional Oracles of the world that could be a function of your HR database. Your HR system can sit on top of Oracle, and we're going to use that as an example. So let's take a moment to break this slide apart and talk about the individual components. Bringing structured to unstructured data, right? So what does this actually mean? Let's make our unstructured data intelligently queryable. And the first step is to discover what you have, right? So putting Symphony into your organization, you can give it access to basically do discovery of your unstructured data. How many times are you storing the same file over and over again? Are there orphan files due to people leaving the company or changing roles? Just get more insights around the security of what you already have. And once you scan everything, the next step is to make a metadata catalog, which is its own database of relevant, searchable, and actionable information. And the key is it's relevant. Every one of you out there, I kind of looked at the list, you're in different industries. So what's relevant about your unstructured data is going to be different. So the important thing is being able to make a custom schema that is relevant to your business. And the things that you are going to search for, things that you're going to train your LLM on, and make a metadata catalog specific to that. It doesn't have to be everything about all of your unstructured data. It just be looking for specific things. And then we're going to put that into a metadata catalog. And that's what's known as metadata harvesting, right? Which is sifting through all of your unstructured data, cracking the file types. Right now, over 500 supported different file types based on industry and vertical and all the things. And we're going to extract information out that, you know, if you're in the manufacturing world, you're looking for a 2.5-inch screw that you developed 10 years ago, it's going to find it, right? Somewhere in all of your unstructured data, and that's going to pop up within the metadata catalog so that you can search for it and you no longer have to seek it out all on your various file servers and file systems. And then the last thing that you can do is automate in-file tagging. So whereas creating a metadata catalog is making a brand new database, you can also leverage file system tools. And within a file system, the files support the concept of an extended file attribute. And that file attribute can be of any length. An example that everyone can understand is a PDF file. If you open the properties on a PDF file, it says who the file was made by, the original author, the date that it was first made, and then any notes about that file that the author put into the field. For example, if this is a legal document and has a case number attached, you can put the case number in the extended file attribute, and it can be searchable based on that case number. So you can do tagging within the file system itself. The difference is a metadata catalog can be basically queried via SQL, and will give a response very quickly. If you're looking through a bunch of tags within all of your file systems, that search is going to take a lot longer. You're still going to have a search tool that effectively makes a database of all the tags in the back end to make that search fast. But you can do both of those things with Symphony. You can do one, right? It just depends on really what you're looking for and what you're looking to accomplish. So you've made that, let's say, a metadata catalog. You have the intelligence about your business from the unstructured data. What are you going to do with it? Well, data motion. And data motion can mean several things. The first and easiest thing to understand is storage tiering. And we're going to give a good example of what that means when it comes to just moving data across storage tiers, but also as it applies to compliance a little bit later on. With storage tiering, a user sees their G drive and that file is in their G drive the entire time as it's slowly migrating from expensive storage to less expensive storage to archive storage to even to tape. We have partners that allow you to put data all the way to tape, but still maintain basically access within the file system and virtually instant access because they're using storage to cache that. IBM can do that with their new tape libraries. The Grau data can do that. So there's a few options there to push data all the way over tape, but maintain it within the file system itself through basically a stub. And that's the easiest thing to understand, right? Which is I have my information, I have a metadata catalog, and as data ages out and it's not used or it's not part of litigation hold or whatever you're doing, it can slowly make its way out to tape, and eventually, after the retention period is done, can just be erased and removed. What's more exciting is making that available to train your models, right? And we'll go through this example, but very simply, all of your models, again, are talking API, SDK, SQL, but on the back end, that's NFS and SMB. So let's do a basic example of a user, and you've trained the LLM. It's internal, obviously not in the cloud. And you've made your metadata catalog, and part of that information was PII data, right? Are there social security numbers with an 80% accuracy or above? Do I have that within my unstructured data set just lurking about? And let's say that header catalog and a user queried the LLM, queried the catalog, do I have any PII outstanding? And the answer from the catalog is, yeah, you have 10 files that have PII. And let's say you're the attorney working for the company. Okay, great. Through the LLM, can you give me the names of those files? And since you have the rights, because it's gonna consistently check to make sure that you have the rights to ask this question, and you do, since you're the attorney, it's going to give you the name of the 10 files that have PII with an 8% probability or above. And then the last question, and all of that came out of the metadata catalog. So you're basically doing a SQL query, no big deal, not that impressive. The last question, can you please get me those files? Now think about that. A user is talking to an LLM that's talking to an API to Symfony and saying, can you get me those 10 files? Well, where are they? They're everywhere. They could be sitting on a Windows file server. They could be sitting in SharePoint. They could be sitting on NetApp. They could be sitting in Object Store. And the user themselves would never find them, right? But Symfony has access to that. So what it can do is package them. So we're communicating NFS, SMB, S3 on the back end, and we're delivering them to the model via the API. And that is basically a repackaging of that data so that the user of that model can basically see those files pop up and click on them and open it up as a PDF or open it up in a browser or open up whatever. But they're getting that data, and that is data motion, right? That's interesting. Another simpler example would be, again, the 2.5-inch screw. Yeah, we found it. Okay, can you please get me that file? And that same data motion would exist if it was an SMB in a file system somewhere. The last bit is restricting motion, right? So regulatory compliance is tough. And the reason it's tough is because there's so much of it. And if you don't automate it, you are probably not compliant. So the restriction of data motion, right, as part of regulatory compliance, the automated deletion of data once the retention period is done, all of that is motion of the data. And Symfony can help automate that. It can help tag it and move it and delete it or restrict its motion in and of itself. And we'll give examples of that in a minute. The last thing is you don't have to change anything. You don't need to change anything about the back end. I'm not asking you to buy a different type of storage or less storage or move everything to the cloud or do anything weird. So your backend storage can stay the same. And like I said earlier, you probably have some kind of actionable intelligence already. If you're a larger organization, you may have invested in master data management, which, coming from Oracle myself, those are huge projects. Keep that for sure. All of those systems on the right, they've all have databases on the back end, and they all have JDBC connectors. So we can do a direct query to the database behind Varonis, or the database behind Splunk, or an Oracle database. And that can also trigger action. It can trigger data motion. Let me give a very simple example. Let's say you have an HR system, and your HR system sits on top of Oracle. And Glenn Schock, that's me. I retired after 20 years at the company. Let's say I was with your company for 20 years, and now I'm retired. As the system reconciles at the end of the day, right, my HR record is going to go from an active employee to maybe an R for retired. And on the IT side of things, I had an Active Directory login or Entra ID. I had an AWS login, something like that. As people move around companies, what happens a lot is their files get orphaned. And they're constantly backed up and all the things are happening, but no one can access them outside of the administrators of those systems, because the person that made those files, the person they belong to, are no longer with the company, or they've changed organizations or whatever. But what Symphony can do is make a query to that database automatically at the end of every day, look at the date field for today's date, and did anybody become R, right, retired? And what it can do is trigger a motion of all of my data that I had created. So all of my SharePoint, all of my personal directory in a NetApp, any of the object stores, you can basically make automation that says, okay, we're going to make a new bucket in AWS. We're going to copy everything over from that bucket that the person owned into the new one, right? We're not going to delete what they already owned in case it was part of another automation. But we're going to copy that into a new one. We're going to move all their personal files over. We're going to move everything out of SharePoint and dump it in this spot, and then give rights to their manager. So that way, all of my stuff is no longer orphaned, and my manager can decide what to do with that data. This is a very simple example of a trigger via a JDBC connection to a backend database that affects all of my data that I had previously. So you can just create that kind of motion based on triggers of Splunk, or if your DLP Varonis does something, right? The trigger that's important for your business, you can move data around or restrict its motion or do whatever is needed. Okay, very simple and straightforward. So let's talk about real examples. So how to train your LLM. Like I said before, the model that you're training doesn't talk the language of the data that it needs access to. So LLMs don't talk NFS, SMB, right? They talk SQL queries, APIs, webhooks, SDKs, stuff like that. And the LLM is going to ask two types of questions. It's going to ask questions about the data, which makes it a lot faster, right? So because keep in mind, it's retrieval augmented generation. So it has to be able to retrieve the data. And if you've pre-packaged it in a metadata catalog, it can retrieve that very quickly. It can make those queries fast. If it has to scan your entire data state, it's not going to be so fast, right? So you can create that metadata catalog, and we can do a query of that catalog for, again, PII data. And that has to be authenticated, right? Just that query itself. So like, again, 10 files contain PII. The next query could be, okay, get me that data. And the person that makes the request of the LLM to get the PII data may not have the rights, which is why Symphony acts as a zero trust principle data broker. It's going to constantly re-authenticate. Does the user have access to this file? Let's say it's 10 files. Does it have access to the first file, second, third, fourth, fifth, before simply handing the data over in the mechanism that was requested, such as API? right? So on the back end, it's talking NFS, SMB, S3. On the front end, it has to talk the API that made the request. So the LLM can deliver the data to the user. This dramatically improves performance. It improves training since it's really just being trained on the metadata catalog, not on the entire unstructured data state, because you're training that language model to do something very specific. You're not training it on everything, right? You're not going to ask that language model, please find me all the memes that are stored in all of my unstructured data. That's not useful, right? It's probably not relevant to your business, although it would be funny. Okay, let's go through another example. You're going to metadata harvest. In this scenario, we're going to talk about metadata harvesting and data motion around operational technologies, right? So we're going to use cameras as an example for a global auto manufacturer. So this is one use case. And what's interesting about Symphony is that we come in and we talk about one or two use cases. And in the case of this customer, it can blow up to 30, depending on who we're talking to and what they see when we discuss this, because intelligence and motion is very generic depending on what part of the organization we're talking to. In this case, we're going to talk about three different parts of the organization. Every part of the manufacturing line here has cameras on it, and those cameras generate two types of files. They generate the image, and then they also generate an XML sidecar file, which is all the information about the video that's actively being recorded. So what can we do with this? We're going to break it up. One, we're going to extract metadata from that XML sidecar file and put it into the metadata catalog, into a database. So what information is relevant to a manufacturing company about, let's say, the components of the car that's being run on this assembly line? We all know this example. This is not the customer we're talking to, but I'm going to use it as an example. Toyota had issues with their engines recently, right? So they had to do a massive recall. And being able to search on all of the video of when that started and rewind it all the way back to the first engine VIN that had the metal shavings issue and watch where it happened, how it happened, and then at the same time, tag, right? So now that we have the search capability for the point in time, we can add the information about the class action lawsuit, about the case number, about anything else that's relevant to that set of video. We also need to maintain the retention of that set of video, probably a lot longer than any normal set of video, because it is part of a lawsuit, right? And you need to be able to call it back. So if you think about just the complexity of a global manufacturer, they have a lot of video, they have a lot of data. Being able to search for something that's very specific, right, within a metadata catalog, to then call up that information only about the engines, only about this point in time in this location, makes everybody's job a lot easier. So we're extracting that metadata, and then we're orchestrating it, right? We're moving it. So as the data ages, right, we can slowly start moving it and tiering it and pushing it out towards longer term storage. But at any point in time, a query can happen to the metadata catalog, and the request to bring that data back could occur. When could that occur? Well, compliance, right? So if, again, you're part of a class action lawsuit, and you want to do something with that data, and you want to be able to provide exactly the scope that's required for the suit itself, you can copy it out and provide a different file system for your attorneys and for discovery and for all of that. So you can move the data in either direction. And this is one type of use case where being able to sift through mountains of video, mountains of data, and just provide what's specifically needed for a legal discovery is very beneficial, right? Because you know you're not providing too much, and you know that it's exactly what's needed out there. And that's another example, right? This could all also be pushed to a model, right, for the legal team, right, about everything with a case number. Again, in a schema that is specific to the company or a schema that is specific to the model that you're training. We've all found recently that instead of making a large language model, companies are out there making small language models, or otherwise known as expert systems. So you would train one model for legal, a different model for engineering. And those can both be trained off of the same metadata catalog, but you'd probably make a second one with a different schema for engineering compared to legal, compared to design, for example. Okay. I'm opening, it's about half an hour. I'm opening myself up for questions. I haven't seen anything pop up in the chat, but I hope that you found this useful, right? How you can train language models or models in general a lot easier on your unstructured data by making a metadata catalog, by using Symfony to do that metadata harvesting, and go from there.